we're ready to talk about confidence intervals using the t-test instead of the standard normal test. And so what I want to do is I want to find a 95% confidence interval, again using the starting salary for a data analyst in the Midwest. And then we had a sample of 10 starting salaries. Okay, so this is all data from our previous example. And so these are our 10 starting salaries. And what we can do is we can use our confidence interval. And since we want to talk about a 95% confidence interval, what that means is that our alpha is going to be 0.05, right? The significance is 0.05 if we want a confidence of 0.95. And therefore, the value that we're going to look at in general is going to be, so we're going to take our sample mean plus or minus t sub alpha over 2 times s over square root of n, where s is the sample standard deviation. Again, this is a formula that comes right from chapter 8. This is the formula, so you don't need to memorize anything, but this is the formula that we're using. Okay, so that's the formula for the confidence interval for the population mean. So let's jump back to our work, and I wrote everything out and already computed these values just to save a little computing headache, but you can double check me if you'd like. So we already found our mean to be 63.54. This t sub 0.025 value is important enough that I want to talk about where we got that from. Our standard deviation we can again get from R. We know how to find the standard deviation of a data set like the one that we have. And then our n is 10. We have 10 items. Because our n is 10, that means that our degrees of freedom is 1 minus that, so 9. And therefore, we're looking at this value of the table. And the cutoff that we want was t sub 0.025. Let me circle that so you can still see it. So t sub 0.025. That puts us at the value 2.262. Okay, so that's how we get that. And I'll show you also how to compute this value using R. But actually, R does this problem basically for us. And so I want to show you that at this point too. So let's actually go back and let's by hand compute these values, or what I computed by hand anyways. So our value t sub 0.025 was 2.262. Our standard deviation we computed, our n was 10. And when we plug everything in, we end up with 63.54 plus or minus 2.8200. It was like 002 or something. 2.820027 if I remember correctly. Anyways, and this is the confidence interval that we get, 60.72 to 66.36. Okay, so that's our 95%. This is just worth writing, I think. This is our 95% confidence interval. Okay, this is called the t-test. Okay, so we can compute this confidence interval using what's called the t-test. And I want to show you how awesome R is. And so let's jump over to R at this point. Okay, so I'll bring R up on the screen so that you can see it. Hopefully you can see it. And what I did is I typed in our data set already. Okay, so this is the data that we had. And we can compute the mean, we can compute the standard deviation. We know that there's, if I do length, that's the number of data points that we have. So there's 10 data points. And here's a few different things that we can do. So what we want to do is we want to compute a confidence interval using what's called the t-test. And I'm literally just going to type t.test of x, and R is going to do basically everything for me. It's really nice. Put it in, and ta-da, we get our confidence interval. And it agrees with what we found, at least at 2 decimal places. We found a confidence interval when we did this by hand of 60.72 to 66.36. This is more precise than what we had, but there's our confidence interval. By the way, ignore the p-value. We'll talk about that in chapter 9. Ignore what alternative hypothesis is. We'll talk about that in chapter 9. Don't worry about it. And this also gives us the mean. So the reason why that's important is that the mean and the actual confidence interval are usually the 2 more useful things. So the confidence interval is going to be the mean plus or minus whatever the standard error. So if you wanted to figure out what the standard error was, what you could do is you could take this value minus the mean, and that's going to be our error, E. So it was 2.82 I think when we did it by hand, since we were rounding, we had 2.8200. But if we do it according to R, it's 2.82024. Okay, and so that's how we're going to do this with R. This is super nice, super helpful. If I wanted to do a 99% confidence interval, what I would do is I would still do t.test, but what I would have to do is I would have to change the command at the end here. So I'd have to change this to not confidence, but conf level. Conf dot level. I'm looking at my own R commands here. And if you do the 95%, this will be the one that we had before. So this will give us the same value as we had here. So let's do that. So just by default, it assumes that we want a 95% confidence interval. If we wanted a 99% confidence interval, then what we can do is change the 95 to a 99. There's our 99% confidence interval. Super easy. It agrees with everything that we know. The 99% confidence interval is wider. Okay, it has more extreme endpoints than the 95% confidence interval, right? Because if you want to have 99% of the samples have the mean in this interval, you need a bigger interval. If you wanted to do a 90% confidence interval for whatever reason, you could just do that, and that gives you the 90% confidence interval. Okay, and really any value in between, just for fun, let's do a, I know my definition of fun is different than yours, but let's do a 92% confidence interval, fine. And so if that's what you need, that's what you get, and that's how you do it. Okay, so that's it. So in the next video, what I'm going to do is show you how to use R to talk about the t-distribution, basically very similar to the commands for the normal distribution.